Good evening, my YouTube viewers. It's Crystal here. I'm just here because I'm going to give you another code review. And basically, I'm using Sklearn's breast cancer data set, but I'm going to be comparing XGBoost to KNN, and we're going to see which model performs better. And the reason why I'm doing that is because I was watching a video on tuning XGBoost hyperparameters, and I'll have to say this, that I think Sklearn does a superior job on the documentation for their library, and so you're able to figure things out with Sklearn, whereas it's more difficult to figure things out with other libraries such as XGBoost. And so quite often I'll have to look at example code to try to find the answer. So this is a code review to give you some example code so you can see what I did. So the first thing we're going to do is we're going to just read the problem statement from Sklearn, that it says load and return the breast cancer Wisconsin dataset classification. The breast cancer dataset is a classic and very easy binary classification dataset. So this is a good dataset to practice on. And it's also loaded into the Sklearn library, so you don't have to go looking for it. And then after we read our problem statement, what I wanted to do is I wanted to install the most current version of Sklearn. So we do pip install -u scikit-learn. After we've installed the most current version of scikit-learn or Sklearn, we're going to import our libraries. So we're going to import NumPy as NP, and what that does is that enables you to carry out numerical computations and also make NumPy arrays as well as perform linear algebra. We're going to import pandas as PD. That's going to enable you to create data frames and maintain them. We're going to import Seaborn as SNS. So what that is going to do is it's going to, let me just check something, because I didn't see that we had math, and when we do our okay, so this is a classification, so it doesn't matter. I was just worried because we hadn't imported the math library. Because this is a classification, it's okay. If it had been a regression, then we'd have to import math as well. So then we'll import Seaborn as SNS, which is a graphics library that enables you to perform statistics, and it's written on the back of Matplotlib. And then we're going to import Matplotlib, PyPlot as PLT, and I don't think that, oh, let me just see. I don't think we need Matplotlib inline. I don't think that's necessary. It was at one time, but I think the computer system has gotten more sophisticated. So we're going to import Matplotlib, which is a graphics library as well, and enables you to perform graphics. So after we've imported the libraries that we're going to want to use, and we're going to load the files. And so from Sklearn datasets, import load breast cancer, xy equals load breast cancer, return xy equals true x. So in Sklearn, they have a facility that enables you to be able to create a data frame. And I tried to create the data frame, and it just didn't turn out the way I wanted it to turn out. So we're just giving you the X and the Y axis. But you can actually create a data frame if you go into Sklearn, and it says right here, and you come over here, see if it'll come up. Load breast cancer. It's a toy data set. It has the facility to enable you to create a data frame. And I tried to create the data frame and it just didn't turn out the way I wanted it to turn out. So I used return XY. And then so you've got it gives you your X and your Y. So we've got our X, which is an array, and we've got our Y, which is an array as well. So we plot a graph in 3 dimensions. And so you can see that this is what the data points look like when we plotted it in 3 dimensions. So now what we're going to do is we're going to normalize X. And so what we're going to do is we're going to take all the values of X and convert them to a value between 0 and 1. And then so when we do that, it's easier for the model or the estimator to make predictions if all of the values are between 0 and 1. So that's what we do. And this is the formula for normalizing data is X equals X minus X min over X max over X min. And that's your formula, and it will convert all of the cell values to a value between 0 and 1, and that's what you want. So now what we're going to do is we're going to take X and we're going to convert it to a data frame. And you can see that there are 30 columns of data. If it had been a proper data frame on S-frame, then you would have known what the columns of data were. But because we had to convert it to a data frame from XY, you just get a number from 0 to 29. But I can show you what it would look like on the data frame, and that's why I decided just to use XY instead of S frame, because it just didn't turn out the way I wanted it to turn out. And so you can see why here you've got a bunch of 1s and 0s, and the reason why is because this is a binary classification. So it's going to just be 1s and 0s. So now what we're going to do is we're going to analyze the Y, which is your target. And so you've got more 0s than you have 1s. So I'm going to assume it means you have less 0s than you have 1s. So I'm going to assume it means that of these people, they're going to have less people that have breast cancer than do have breast cancer. So I'm just going to work on the assumption that a 0 is no and a 1 is yes. So we just did a little box plot of it, and you can see this is your box plot. It's just a box between 0 and 1. So what we had to do is we had to convert Y to a data frame, and the reason why we had to convert Y to a data frame was to get it to work with the model. And you know, X is in a data frame as well. So cancer equals Y dot value counts. So we had to convert it to a data frame to get it to work with the value counts, because if it's just an array, value counts doesn't work. So you had 357 1s and 212 0s. So I'm just going to assume that 0 is no, they don't have cancer, and 1 is yes, they do. And then so we want to look at the percentage. And so you have 62.7% are 1s and 37.2% are 0s. And now we have a heat map. And so this is a heat map that gives you the correlation between all of the columns. And so the dark color is a low correlation and the light color is a high correlation. And so you can see that we've got 30 columns of data. And so what we're going to do now is we're going to remove the columns that have a high correlation. And I've done this before. I have done this before, and fortunately, there were 30 columns, and because the columns had a high correlation, they were able to filter out 10 columns. So instead of having, instead of having 30 columns, now they only have 20 columns. So what is going to happen is it's going to be easier for the estimator to actually make predictions on less columns of data. So we've been able just to deleting the columns that have a high correlation, a correlation of greater than or equal to 0.9. We were able to reduce the number of columns down from 10 columns, from 30 columns to 20. So that's good. So it's going to be easier for the estimator to estimate. And now what we're going to do is we're going to split our X into training and validating sets. And so you've got Y as being a data frame, and because Y is being a data frame, so Y equals Y0. So Y is the first column of that data frame, because if you don't make Y a data frame, then it won't work when you try to put it through the estimator. So that's why you have to make Y equals Y0. The Y0 means it's the first column of the data frame. And then we use Sklearn's train test split to split the data frame up into training and validation sets. And we're also going to shuffle it. So we're going to shuffle everything as well. So, and the training set is 90% and the test set is 10%. So the first thing we're going to do is we're going to check XGBoost, and then I've set XGBoost to have some parameters. So when we train the model, we got 100%, but when we predicted on the model, we got 96.49%. And I tried really hard by playing around with the parameters to get the accuracy improved, but I personally couldn't get the accuracy up. So maybe somebody else knows some different hyperparameters to use or different settings to use. I also tried to set it up with Grid Search CV, and the reason why I did that is because I found a website that said you could use Grid Search CV with XGBoost, and so I set it up for Grid Search CV and waited a long time for it to go through the cycle through the system, and at the very end it crashed because it said that XGBoost doesn't have a best params function. And so it didn't work, and because it didn't work, the only thing I can do is just try to play around with the parameters myself. And see, that's one problem you have, because obviously I'm learning programming on my own, and so the only thing that I can do is look on the internet and try to find code on the internet. And a lot of the code on the internet doesn't work. I don't know, maybe like when people run the code up on their own PC, it works, but it certainly doesn't work on Google Colab. And like this business with Grid Search CV didn't work on XGBoost, so I couldn't do it. So you can see we have like 100% when we trained and fitted the model, and you can see with the model, we can see what the estimator is. And then when we predicted on the validation set, we've got 96.49%, and you can see we have all of our ones and zeros, which is YPRED. So we put the predictions up through a confusion matrix, and you can see that there was one that wasn't cancer, one that wasn't cancer, but they said that they did have cancer, and one that was cancer and said that they didn't have cancer. So you wouldn't want to be that one person that you did have cancer and they told you that you didn't have cancer. And that's why you have to try to get your predictions as high as possible. So like when you're predicting on something like cancer, you want to make sure that you get your predictions as accurate as possible, because you don't want to tell somebody they do have cancer when actually they don't, and you don't want to tell somebody that they don't have cancer when actually they do, because if you tell them they don't have cancer when actually they do, then what would happen is the cancer would spread and it would become much more difficult to treat. So that's one of the good things about machine learning and making predictions and things. So we created a data frame so we can compare the validation set against the YPRED, so you can see that for yourself. And then now what we're using is principal component analysis to actually see the error. So you can see, you should be able to see the errors, but I personally can't. Oh, I think that there's one red one in there, so that was the one mistake. And now what we're going to do is we're going to put it on KNeighbors classifier, which is an Sklearn, and we're going to use the hyperparameters that I used when I had used Grid Search CV, although I didn't use Grid Search CV on this one. I have used it before. We had 100% accuracy when we trained and fitted the model, but when we predicted on the validation set, we only had like 92.9% accuracy, which was close to 93. So we had 93% accuracy with KNeighbors, and we had 96.5% accuracy with XGBoost. So 3.5 points. XGBoost was 3.5 percentile better than KNeighbors. And so that's the point. A lot of data scientists are saying, you know, how good XGBoost is. And so what I wanted to do is I just wanted to compare XGBoost to Sklearn estimator and see what see if it was true, see if XGBoost does actually outperform Sklearn estimators. And so we checked our confusion matrix, so you had 16 zeros, or 16 not cancer, and so one person, they told them that they had cancer when actually they didn't. And you had 37 people who did have cancer, but you had 3 people who did have cancer and they told them they didn't have cancer. So again, the accuracy with KNeighbors is less than it is with XGBoost. And then so we created a data frame so you can compare your true values with your predicted values. And we use principal component analysis where you can look at the mistakes. And if you look in there, there are 3 little red dots, and those 3 little red dots are telling you the errors. And so that concludes our code review. I hope you got something out of it, and so you got some code on how to remove columns that have a high correlation. You got that code, and then in addition to that, you got to see for yourself that XGBoost outperforms KNeighbors. So I'm going to go ahead and conclude this code review because I've covered everything I wanted to cover. And I want to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you so much for watching this video. And I look forward to making other videos for you in the future.